There are two ways to go about solving a complex figure like this. I like to call them the buckshot method and the planned out method. Right? Buckshot is you just start anywhere, you just start filling in whatever you can, and eventually, if you fill in enough, you'll be able to get your variable. That will work, but it might produce extra time and effort that could be saved if you actually plan things out a little bit. So, for example, these are two regular polygons. We could actually say, well, could we get angle A by that pentagon? Sure, we could get angle A. Let's not get it yet. Could we get angle B? Yeah, it's a hexagon, regular hexagon. We can definitely use our n minus 2 times 180. But again, let's not necessarily get it yet, because what we can do is plan, and if we can not get one of them, it'll save us some time and effort. So we can get these, of course. That means that's angle A and that's angle B. Down here, these are all might be useful. We know that this is angle B, and of course this is angle B. And you notice I'm not really filling these in particularly because they're not kind of around x, so we're probably not going to need those. Now x is kind of off to this side, so I might want to work over here. I mean, here's this nice triangle right here. If we know B, could we get this angle C? Well, yeah, those are linear angles. We could get that. Well, if we could only get that angle, then these are linear angles also, and we could get x. Well, if we could get this angle D, then we could certainly get angle E. So it really comes down to this angle D. Well, how do we get that? Once we get that, everything else falls into place. Well, you'll notice that these two lines are parallel. We're given the parallel signs. So this 96, well, that can be brought over right over here. That's 96, and I can do that. And it is because those are corresponding angles. Now we can get D. So at this point in time, we have everything planned out, right? Starting with this corresponding angle pair, 96, we can get D. We can get C once we have B. Then we can get E. We can solve for A. Notice, do we need A? Actually, the answer is no. We don't really need A. If we never got A, we could still solve this. So let's save ourselves some time and effort, and let's not calculate A. So let's start. We have to calculate B. I'll do that maybe up here. And what's going to be very important, I'm going to show you the format for the communication piece. How do you show your work? There's a lot of work that ends up happening with these complex figures. And if you're not organized and clear about it, it just looks like a mess. So I'm going to start off with, of course, my sum of the angles equals n minus 2 times 180. Now this is a regular hexagon, so there are 6 B's in total, 6 sides, and so we have 6 minus 2 is 4. 4 times 180 is 720. We divide that by 6, and B turns out to be 120 degrees. Now here's where the communication piece comes in. This is one sort of cohesive piece of work. We're done with this. We're going to be moving on to the next piece. So what we're going to do is put a box around this so that it can clearly be identified as an independent piece of work. And then what we're actually going to do is put a flag on top and mark it with a 1, because this is the first box. This is the first major piece of work we've done. So these numbers are going to allow me as your grader to be able to see the sequence of your work. You did this first, and then you're going to what you did next, and it all makes it very readable, which is very important. So now let's maybe get angle C. All right, so we have linear angles, right? Using my vocabulary, again, part of communication. So we have C plus B equals 180. We know what B is now, which is 120. And we can solve for C, which turns out to be 60 degrees. Right? And again, what we can do is box around it. And I guess I'll throw the flag on the side over here. This is number 2. It is sometimes helpful. You can, if you want, put the numbers onto the figure. Right? We figure out C is 60. Right? In order to get D or E, we have to get D first. Right? There's a sequence here. So D and 96, those are linear. Linear angles. So we have 96 plus D is 180. We solve for D, and D would be 84. Box. Looks like maybe I have to put the flag down here. That's the third one. So we know that this is 84. So now we know that this triangle here, I'm going to highlight this just so everyone can see it. We're now working with this triangle. We know 2 of the angles. So really this is, just like over here, this is a sum of the angles of a polygon. So we could actually start off with the same equation. Now at this point in time, there are certain polygons which most people will know what they add up to be. A triangle is one of the basic, the smallest polygon. The 3 angles of a triangle add up to 180 degrees, right? And you can test that. You know, for a triangle, what's n? N is 3. Well, 3 minus 2 is 1. 1 times 180, well, that's 180. So a triangle always adds up to 180. So we can actually use that. So 60 plus 84 plus E equals 180. And we could, if we wanted to, sum of a triangle equals 180. That's probably the clearest way to communicate that. So this would be 144 plus E. And solve. And E turns out to be 36. And we can box that one carefully. That's number 4. So we really have everything that we need to solve for x, because now what we have is linear angles. And we have E, which is 36. We have B, which is 120. And we have X, which has to equal 180, the straight angle. So this would be 156. And we can solve for X, which would be 24 degrees. Right, again, don't forget box, and it took us 5 steps, right, to solve for our answer of 24. So 2 things going on, or actually really 3 things going on here to recap. All right, there's a couple ways of solving complex figures, you know, buckshot method versus really planning it out, and really make sure to label using these letters, and much more clear. If you just start off by solving, like we could have solved for A, it would have been somewhat unneeded work. So if we planned it out, we save ourselves from work. So we have those kind of 2 methods for solving complex figures. And very importantly is the system for communication that I want you guys to use for complex figures with boxes and flags. Notice that within each box there's a coherent equation that we work vertically. There's the equal signs are typically lined up, and you can solve using relatively small steps so that it's very clear.